Okay, hi everyone. I'm going to talk about the atrial fibrillation. So first of all, we're gonna determine the rhythm. The rhythm in the atrial fibrillation is going to be irregular. Okay, so irregular. Just when you see the rhythm, like when you take a look here at the rhythm, you're gonna notice that it's going to be like regular, since there's no equal distance between each R wave. So the atrial fibrillation, the rhythm going to be irregular. What do we mean by atrial fibrillation? Atrial fibrillation means when the atrium is beating so fast. So this is what does it mean? Okay, how could we determine the rate? Okay, so the rate, because it's irregular, we're gonna sorry, we're gonna take the 6. 6 is a fixed number, and then multiply it by 18. Why do we multiply it by 18? Because 1, 2, 3, this is when you just count the numbers of the R waves. It's going to be equal to 18. So that's why. So the rate is 18 multiplied by 6, which is a fixed number. It's going to be equal 100 beats per minute, which is considered as tachycardia. Okay, this is about the rate. What about the P wave? It's going to be absent. Okay, why do we say it's going to be absent? Because we hear a problem in the atrium, so it is beating so fast. So that's why it is absent. Okay, so once you see the P wave, there it is an indication that there's a problem in the atrium. As you could just notice here, this is going to be just there's no P wave, no P wave, no P wave, P wave. So there's a problem in the atrium, which is going to be atrial fibrillation. The PR couldn't be determined. Why? Because there's no P wave. So once the P wave is absent, there is going to be no PR. We couldn't determine it. We couldn't see how much the duration of it. So this is why. What about the QRS? The QRS is normal, narrow, and it equals 0.04, which is equal to a small square. Okay, so once here you see this is small square, small square, small square. So it's going to be 0.04. Okay. What else? Just let me erase all of these mess. Okay. This is about the QRS. The CT segment is going to be isoelectric, the T wave normal, and the axis is normal as well. But I wanted to say that once you see this figure right here, you're gonna see there's an atrial fibrillation, because you don't see as well the P waves. There's no P waves at all. There's no P wave. So that indicates that there is a problem in the atrium, and that could be an atrial fibrillation, right? The rhythm going to be irregular, right? Okay, so this is something has to be mentioned, because the rhythm irregular not just the same as the atrial flutter. Okay, how could we measure the rate? This is the P wave going to be absent. The PR couldn't be determined because there's no P wave at all. QR is normal because there's basically the problem is the atrium, so P wave doesn't exist. The QRS is related to the repolarization of the atrium. I'm sorry, no, it's about the depolarization of the ventricle, so that's why it's normal. Okay, ST segment is normal. And T wave is normal because all of these related to the atrium. So once there's no problem here and those things, that indicates that we have a normal ventricle. Okay, what about the axis? The axis is normal as well because, you know, there's a 1 which is positive. It's positive. So it's going to be like normal. Both are positive, the axis. Okay, that was the atrial fibrillation. The thing here that we have to appreciate that the P wave going to be absent, the rhythm going to be irregular, what else? Going to be tachycardia as well. The other parameters going to be normal. So once you see this figure or this just such this shape, you're gonna write atrial fibrillation. I'm sorry about my handwriting, but atrial fibrillation. Just like, yep, that's it.